Hello geometry students. Today's learning target is to talk about special 30, 60, 90 triangles. Before we do that, let's take a look at the three equilateral triangles on the screen. We have a blue equilateral triangle with side length 4, a red equilateral triangle with side lengths 8, and a green equilateral triangle with a side length of 10. For each triangle, I'm going to draw the altitude. So the altitude forms a 90-degree angle with the opposite side. In drawing that altitude, it cuts the angle in half, so each angle at the top is 30 degrees. And then our focus, as I said, will be the special 30, 60, 90 triangles, which is this blue triangle, this red triangle, and this green triangle. So the goal is to study 30, 60, 90 triangles, so we're just going to focus in on the right half of each triangle. Now when you draw that altitude, the yellow piece that I just highlighted, I'm hoping that you could visually see that that is half of the base. So the yellow triangle, so in the blue triangle, half of 4 is 2, so the yellow piece is 2. In the red triangle, the base is 8, so half of 8 is 4. And in the green triangle, the base is 10, so the yellow piece is half of 10, which is 5. So that's worth noting, and I'm going to draw that over here, that in a 30, 60, 90 triangle, if you know the hypotenuse, the side across from the 30 is half of the hypotenuse, and that pattern always works. And some people call the side across from the 30-degree angle the short leg. And in fact, some people call the side across from the 60 the long leg. So what I just did here is I took the 30, 60, 90 triangles out of the picture so you could see that pattern. So once you know the hypotenuse, you would take half of the hypotenuse to get the short leg. And remember, the short leg is across from the 30-degree angle. So if the hypotenuse was 20 and I had a 30, 60, 90, then the short leg, the side across from the 30, is going to be half of 20, which is 10. So the short leg, I'm going to write this formula down, is always half of the hypotenuse. Now we want to find the long leg, or the side across from the 30-degree angle. So I'm going to go back to the Pythagorean theorem, and I'm going to call these sides x. And for each problem, I'm going to set up the Pythagorean theorem. So x squared plus 2 squared is equal to 4 squared. In the next triangle, it would be x squared plus 4 squared is equal to 8 squared. And in the green triangle, it would be x squared plus 5 squared is equal to 10 squared. I'll solve the blue triangle. So x squared plus 4 is equal to 16. I'll subtract 4 from both sides. So x squared is equal to 12. So x is equal to the square root of 12, which is the square root of 4 times the square root of 3. So x is 2 square root of 3. I'm going to pause the screen if you want to solve one of those problems and then come back and see if you are correct. So in solving for x, you could see all the work, and let's add that to our diagram. So in the blue triangle, x is going to be 2 square root of 3. So I'm going to replace these x's with the answer. So in the blue triangle, we have 2 square root of 3. In the red triangle, we have 4 square root of 3. In the green triangle, we have 5 square root of 3. So now let's look at this pattern. If you know the short leg is 2, notice the long leg, or the side across from the 60, is 2 root 3. If the short leg is 4, long leg is 4 root 3. If the short leg in the green triangle is 5, the long leg is 5 square root of 3. So in the example that we were doing, if we know the hypotenuse is 20, you take half, so the short leg is 10, and then the long leg is going to be 10 square root of 3. So let's summarize the relationships. So I'm going to draw this nice and large. So when we have a 30, 60, 90, we have the hypotenuse, we have the short leg is across from the 30, the long leg is across from the 60. And we learned, I'm going to do an example here. If the hypotenuse is 100, to get the short leg, which is across from the 30, you take half of the hypotenuse. So half of 100 is equal to 50. And then we also learned that across from the 60-degree angle, if you look at the pattern, it's always 2 times the short leg. So I'm highlighting this in yellow. So you'll notice we have the short leg is 5, long leg 5 root 3. Short leg 4, long leg 4 root 3. Short leg 2, long leg 2 root 3. So in the example that we were doing, the long leg is 50 square root of 3. So I tend to say in the picture on the left that the short leg times the square root of 3 is equal to the long leg. So let's put all that together now and kind of write out the formulas. So we have the hypotenuse, we have the short leg. Remember, the short leg is always across from the 30. We have the long leg. So the short leg is always half of the hypotenuse. The long leg is always the short leg times the square root of 3. Some people will also say, well, what if I was given the short leg? So if I tell you that the short leg is 20, some people will say, well, how do you get the hypotenuse? Well, that's the reverse. So 2 times the short leg is equal to the hypotenuse. So to get the hypotenuse here, you would say 20 times 2, or 40. The long leg is still the short leg times the square root of 3. So these are some of the main ideas in the special 30, 60, 90 triangle. And on the SAT, some people label the hypotenuse 2x, the short leg x, and then the long leg x square root of 3.